Hi everyone, today I'm gonna talk about the Hammett plot, which is a powerful technique in deciphering the reaction mechanism. The topic itself is highly challenging as it involves the conceptual idea of electronics. To come up with some idea of the Hammett plot, I went through some literature and even my textbook, which was helpful to make this video. When someone traces back the Hammett plot, it's named after a chemist Louis Planck Hammett in 1934. This explains how a reaction mechanisms vary as a function of electronic changes induced by the substituents. Here, the electronic changes includes the effect of field resonance, inductive, and polarizability. Basically, Hammett plot gives the idea of sigma and rho, which are the key factors in explaining the reaction mechanisms. Well, before explaining the reaction mechanism based on Hammett plot, let's look at the sigma values. Typically, the Hammett plot uses ionization of benzoic acid and the substituted benzoic acid as the reference example. We can define sigma as the ratio of acidity equilibrium constant for the substituted benzoic acid to the benzoic acid itself. But then, is there any significance of the sigma values? Yes, definitely there is. When we look at the sigma values for the different substituents, we can see a trend. If we look at the electron withdrawing groups like cyano and nitro, there is not much difference in sigma meta and sigma para values, whereas for the electron donating groups like amino and hydroxy, there is a large difference in the sigma meta and sigma para values. So that makes sense in explaining the reaction mechanisms. Now let's take an example of methoxybenzoic acid and use our idea of sigma values to explain this reaction. When methoxy is at meta position, it pulls the electron by induction, whereas if it's at para position, it donates the electron by resonance. Induction is responsible for the positive values of sigma, whereas the resonance gives the negative value of sigma, which is minus 0.12. This shows that the more the resonance, the more positive is the sigma, and the more the inductance, the more negative is the sigma values. And if there is negative sigma values, it can be stated that the substituted benzoic acid is less acidic than the benzoic acid itself. After the sigma values, let's talk about the rho value, which is another important parameter of a Hammett plot. Now that a scale for substituent effect has been established, we can determine if other reactions respond to the substituent the way the benzoic acid does. The goal is to use benzoic acid ionization as a reference reaction that creates a negative charge and compares other reactions to it as a means to see if they also create a negative charge or conversely a positive charge. Furthermore, we want to determine if different reactions are more or less sensitive to the substituents than are the acidities of the benzoic acid derivatives. To do this, we use the Hammett relationships given in the following equations for the thermodynamics and kinetic analysis respectively. To determine rho, plot of log kx to ks or log kx to ks versus sigma x for a new reaction under study is done. Rho is simply the slope of this plot. Of course, the rho describes the sensitivity of new reaction to substituent effects relative to the influence of the substituents on the ionization of the benzoic acid. It's also called the reaction constant or the sensitivity constant for each new reaction under study. The values of the rho lead to the associated conclusion. First, when rho is greater than 1, the reaction under study is more sensitive to the substituent than the benzoic acid and the negative charge is building during the reaction. And when rho is in between 0 to 1, the reaction is less